तो माता लोगों ने 10 तारीख माता रिमाइंड के छजी दा टाइम बस रही माना एर नहीं करा जदी प्रेशर करा मां फोन नंबर इस्ता okay now we come to I'll again switch to hydrogen atom in later stages, but before that I would like to discuss the angular momentum of a particle. Now, you know, linear momentum of a particle is P, which is equal to mv, right? M is the mass of the particle and v is the linear speed of the particle. Then this is how it defines linear momentum. Then is angular momentum, that is denoted by L. And if you want to have a similar expression like this, then that is equal to I omega. I is the moment of inertia and omega is the, so m is replaced by moment of inertia and omega is by angular speed, okay? But the relationship between L and P is that L is equal to R cross P. This is classical definition of angular momentum. That if a particle is moving in a circle of radius r and at each point a speed is, you know, because it's a vector quantity varying, so momentum is varying, so it is cross product of the radius vector and the momentum vector, and that is equal to L. Now, this L is always perpendicular to plane which contains R and P. You know it from the cross product of two vectors. Now, if somebody says, what is, how angular momentum is defined in quantum mechanics, you say, we define it in the same way, but we write this symbol at the top of that. In classical mechanics, you can write it as minus P cross R. Here you cannot write it as minus P cross R. You cannot write it. Why? Because R is an operator and P is operator. P is equal to I H bar delta over delta x, maybe with minus sign, or maybe I don't remember it. Lekin ye operator hai, so it means R is operating on P, P is not operating on. Here doesn't matter because over there we don't use that. So you have to be careful that in quantum mechanics use always L is equal to R cross P. In classical mechanics you can use that as well. Okay. Then it has three components. Okay. How we can write it three components? It is one thing more. In quantum mechanics, it is vector as well as it is operator. This is why we are using this symbol. Vector as well as operator, use this symbol. Here it is only vector. No, not an operator. So L has three component, Lxi plus Lyj plus Lzk. You don't worry why I haven't written this there, because this makes it vector and this makes it operator. This I make. Here there is no such thing. So this is why this symbol is used here and this symbol is not used here. Okay, so remember that is the 3 component, and that is equal to xi plus, this is for unit vector, okay, plus yj, and that is for operator, plus zk cross pxi plus pyj plus pzk. And you can write it always in the determinant form ijk, right, px, sorry, x, y, z, that is this, and px, py, pz, which is equal to I ypz minus zpy minus j xpz minus zpx plus k xpy minus ypx. Therefore, from here, this is concluded that I will be equal to that. Therefore, Lx will be equal to ypz minus zpy. Ly will be equal to, take minus there, zpx minus xpz, and Lz is equal to xpy minus ypx. These are the 3 components of orbital angle. Yes, but here was minus, here is no minus. Okay, so I have taken minus inside. This will become plus, this will become minus, right? Okay, so classically, these are the 3 components of orbital angular momentum. Says, what are the expressions? What are the expressions in quantum mechanics देखिए मैं वो ऑपरेटर की एक्सप्रेशन एग्जैक्टली यूज करना चाहता हूँ. दिस इज व्हाई आई यस px is minus ih bar delta over delta x. So in quantum mechanics, Lx is equal to y minus ih bar delta over delta z minus z minus ih bar delta over delta y. And this will be further equal to Lx, or this is minus, there is a minus here as well. Okay, you take minus outside, right, and it will be y delta over delta z minus z delta over delta y. इसी तरह Ly will be equal to minus ih bar z delta over delta x minus x delta over delta z, and Lz is equal to minus ih bar x delta over delta y minus y delta over delta x. So these are the corresponding 3 components in quantum mechanics, because now we have written them in the operator form. we have written in the operator form. I am just going to check. This is ypz minus zpy, zpx minus xpz, xpy minus ypz, and that is y delta over delta z minus z. This is, there is no minus with every one here, okay? Please check it mathematically, okay? Okay, why it is not there, okay? So that is IH bar, yes, it is IH bar, that thing. So these are the four equations. Now, it can be shown that Lx and Ly, these two components of orbital angular momentum, they do not commute with each other, and answer is IH bar Lz. Similarly, Ly Lz is equal to IH bar Lx, and Lz Lx is equal to IH bar Ly. Now remember, these two do not commute, these two do not commute. Look at the order. After x it is y, after y it is z, after z it is x. So keep that order. If you reverse the order, okay, reverse the order, put negative sign. Now if you replace Ly here, Lx there, then put negative sign there, put negative sign there. So what does this indicate? This indicates that no two component of orbital angular momentum, they commute with each other. However, if you take L square, which is Lx square plus Ly square plus Lz square, that is dot product of L with itself, it will L square, then L square and Lx, it commutes with each of the three components. It means that delta L square, delta Lx, it doesn't have uncertainty product. The physics says that no two components of orbital angular momentum, they commute with each other. It means that if you are making simultaneous measurement on the two components of angular momentum, Lx and Ny, you will have uncertainty. Okay, and uncertainty delta, you will have delta Lx, delta Ly, delta Lx into delta Ly of the order of h bar over 2, etc., etc. And similarly here and similarly here. Okay. Now, if you reverse the order, then of course you will put minus sign, but that will remain the same. If you say delta Ly, delta Lx, that is because in derivation that was in the 2 parallel bar. But if you take a square of this, very strange, it's a very strange thing and very strange phenomenon, individual component do not commute, but when you take a square, then square commute with each and everything. So it means that angular momentum L operator, it is not a good quantum number. However, if you take its square, then it is represented by a good quantum number. L does not represented by a good quantum number because there is uncertainty in its component. लेकिन square करें तो that uncertainty is gone. I'll show you that mathematically. Now, I want to discuss some physics of it. When you say orbital angular momentum, this is always measured in the unit of h bar, and it is always integral, and it takes orbital angular momentum quantum number takes values L is equal to 0, 1, 2, 3, etc. Right? You know this what you have learned in modern physics, orbital angular momentum quantum number is L is equal to 0, 1, 2, 3, 4, etc. Right? And these are the semi-classical value. But the correct value for L is for given value of L, this L takes this value L into L plus 1 square root. Have you seen that? अब जरा मॉडर्न फिजिक्स देखें उसमें कि for a given angular momentum quantum number, this L takes these values. That is the magnitude of L, not that one. Because there is uncertainty there, and look how uncertainty comes there. If you have orbital angular momentum quantum number 1, then this will be 1 into 1 plus 1 square of 2, which is 1.414. It means these factors come from uncertainty. Now I'll take you to another. Let's say you are talking, and this I will give you a problem sometime later. This is one proton, an electron is there. Somebody says, where will be electron? You say under normal condition it should be in n is equal to 1. And when in n is equal to 1, its orbit is r1, and that is equal to, if you put the value a0, which is 0.52 into 10 to power minus 10 meters. If says what is in 2, the general formula is Rn is equal to n square a0, because this 1 and R2 means 4 a0 and etc. Now this is a fixed value. This value of R1 which you calculate by making use of Bohr theory, which is a semi-classical theory, then it gives you exact value 0.529 into 10 to power minus 9 meter, that electron in the normal state of hydrogen will be moving in this orbit with this radius. If you say n is equal to 2, then you multiply it by 4, you will get that.